ch13, Chapter 13, Sinusoids continued. We have the general format for a sinusoidal voltage or current. It's A sub m times the sine of A, which is equal to A sub m times the sine of omega t. AM is the peak value of the waveform. So when the waveform's going up and down like this, it's the top or the bottom of the waveform. The bottom is usually below the zero axis, so it's going to be negative. A, or omega t, is a unit of measure on the horizontal axis in degrees or radians. And then theta is the phase shift. That's also in degrees or radians. And that's just pushing it to the left or to the right. So the current and the waveform, general speaking, would look like this. Voltage would look like this. Some trigonometry definitions. Cosine of A equals sine of A plus 90. I'm not going to read all these off, but this is how you convert. Sometimes you're given a problem in a cosine form and you have to figure it out in sine form. This is probably the most common one that you're going to see. Or negative sine of A is equal to cosine of plus or minus 180. Negative cosine is equal to A plus 270 or minus 90. Sine of negative A is negative sine of A. Cosine of negative A is cosine of A. Theta t, which is the phase relationship between two waveforms, would be the phase shift of the first waveform minus the phase shift of the second waveform. This is another formula here. It's just showing you the relationship that we have, derived from one of these, or a combination of these formulas. So the theta is the phase shift. It's not the number of divisions. If you're looking at it like an oscilloscope, it shows the waveform on the screen. Theta is the number of divisions of the shift between the two waveforms divided by the number of divisions times 360. T is the period. Phase shift is the number of divisions between the two waveforms. Theta is the degrees of phase shift. Both waveforms need to have the same frequency. Example would be 60 Hertz. Average value. It's the average value of a waveform, which would be the algebraic sum of the areas under the curve divided by the length of the curve. The vertical shift is of the DC component. If you add it to AC, then it shifts the whole waveform up or down depending on what the value is of the DC level. Effective RMS values. Square root is a square root function. IRMS equals IM, which is the maximum peak waveform current, divided by the square root of 2, which is also 0.707 times the peak, and that goes for the voltage too. So for AC plus DC sources, VRMS equals the square root of the DC component squared plus the voltage AC RMS squared. VRMS is the total RMS value. VDC is the voltage value, and VAC RMS is the RMS value of the AC waveform. Converters and inverters. A converter would be like an adapter, like a cell phone charger. It takes AC voltage out of the wall, converts it to DC voltage. An inverter takes a DC power supply and converts it to an AC source. An example of that would be a device to use in a car plug that you can then plug a 120 volt device into. And then a rectifier converts AC power into a DC source, like industrial 250 volt DC cranes.